quarks in the supersymmetry inversion model actually are positron and electron pairs. So the up quark is negatively charged, so you would say it was an electron, but actually it's a positron. So as the quark is generated, it's inverted its charge in that inward trajectory through the singularity, which means that the negative up quark is actually a positron and the positive down quark is the electron. If we look at the internal geometry of the singularity and the up quark and down quark, then we can see a similar geometry to the electron and positron. So in the SUSY inversion model, we have two quarks surrounded by the third quark in the proton and two quarks surrounded by the third quark in the neutron, and they're opposite each other, so that the neutron external surface has a negative charge and the proton external surface has a positive charge. So in the SUSY inversion model, we have the bubble, which has an internal charge on the inside surface and an external charge on the outside surface of the bubble, and they're opposite charges. And when it goes through the singularity, it can invert the charge from the inside to the outside or the outside to the inside. And in this way, the positron can become the electron, and in this way the up quark, which is negatively charged, it could become the positron in the orbital layer, and the electron in the orbital layer becomes the down quark, which is positive. So this mirrored symmetry of opposites provides context for the inward trajectory and the gravitational process which takes light down to the singularity. And in this supersymmetry model, the neutron has an overall charge of -1 and the proton has an overall charge of +1. And here we've got gluon fields between the quarks, internal, and we have the meson field of light between the neutron and the proton. So this way we've got both a two-layered system, and we've got some mathematics that allows the determination of this process, where one of the electron-positron pairs, one expands and one contracts. So it's expanded through the square root square process, and the electron size of 4e to the -18, one of them goes down to the singularity, which is 4e to the 18 squared to the -18 squared, and that takes you down to 1.6e to the -35 of a meter, and the other one's square rooted, which is 2e to the -9 of a meter. So that gives context for the larger sphere and the smaller singularity and the inversion event that occurs, and then the relationship between those two corresponds to the positioning of the electron in the orbital structure and the other quark surrounding the gluon fields. So it's a completely different model from electrochromodynamics. It doesn't look at three quarks within the the nucleus of an atom for the proton and the neutron, hadrons. It looks at a mirrored symmetry stability model of +1, -1 for the positron-electron pairing as the quarks. And this way we have a consistency of how photons of light are involved in forming quarks, and the stable state of neutrons being -1 and protons being +1, and why mirrored symmetry in the atomic singularity provides stability.